Hi there, this is a video about parallel and perpendicular lines. Let's first talk about what parallel lines are, and these are two lines that don't touch, all right? And if we draw a pair of parallel lines, I'm simply going to draw two lines that are next to each other that have arrows on them to indicate that they're parallel. Now, perpendicular lines, these are lines that intersect at 90 degrees. And if I draw a picture of that, I draw two lines with arrows on each side, and then I draw a square in there, and that's going to indicate that they intersect at 90 degrees, okay? And in this video, we're going to extend some of these ideas of perpendicular lines and parallel lines and some of their properties. Now, the next thing I want to talk about is this concept of the shortest distance between a point and a line. So I have a point here and I have a line. And what we want to figure out is what's the shortest distance between this point and this line. Now, what we can do is we can come in here and we can say, you know, any distance between this point and a point on that line, you know, we're going to have a bunch of different options here. But the one that's going to be the shortest is the one that makes a 90-degree angle. So when you come in here, the one that makes a 90-degree angle is your shortest distance, okay? And so to talk more about this, shortest distance between a point and a line is a perpendicular line, okay? The next thing that I want to talk about is this concept of skew lines. And those are two lines that are non-coplanar that do not intersect. So skew lines is a little bit different than parallel lines. Even though parallel lines do not intersect, neither do skew lines. However, parallel lines are coplanar. All right, so let's look at an example. So in this example, what I want to show is that I have two planes here. All right, so I have one plane here and one plane here, and these planes are parallel planes. However, the lines that are on those planes are what we call skew, meaning that they're not on the same plane and they won't intersect, okay? The next thing that I want to talk about is this concept of the perpendicular bisector theorem. Now, to talk about what a perpendicular bisector is and what it does is pretty much what it says. It's something that's perpendicular and bisects something else, all right? So let's write in here a segment that we'll call AB, okay? If I wanted to draw in a perpendicular bisector, what I'm going to do is I'm going to create another line here, like so, and we'll call this CD, okay? And so CD, what this does is it's a perpendicular bisector to AB, meaning that it's going to cut, and let's put a point here, which we'll call E, all right? And what this line CD does is it cuts this line in half so that these two segments are congruent. AE is congruent to EB, and that we also create a 90-degree angle here, okay? So now because of that, all right, what the perpendicular bisector theorem states is that if you have a perpendicular bisector, CD, then any point along your perpendicular bisector is going to be equidistant to your endpoints. All right, and so here's what I know. All right, so let's draw in a segment, say CA and CB, okay? What I can say about CA is that that segment is going to be congruent to CB. All right, now we can also come in here and say AD and DB, all right, connect those two segments, and we can say that AD is congruent to DB, all right? So that's the idea. That's what a perpendicular bisector does, all right? Not only does it take your segment, cut it in half, make a 90-degree angle, but you also get any point from your perpendicular bisector to the endpoints of what you bisected is going to be congruent. All right, so let's take this example and let's apply it to a couple of problems. So on this example, what we are being instructed to do is to answer the question, what is the length of segment AC? Okay, so here's the segment AC, all right, and we're trying to figure out what the length of it is. Now, here's what I know, is that DC is a perpendicular bisector to AB. Because I know that information, what I know is that AC is congruent to BC. All right. So anytime I've got something like this, I will come in and label my picture as such. All right. And label what sides are congruent to what. Now, if I wanted to set up an equation to solve for x, because I know that BC is congruent to AC, and let's write that out here, that BC is congruent to AC, then what we can figure out is what this value of x is, all right, by setting up an equation, okay? If I substitute 3x plus 2 in for BC, so write 3x plus 2 is equal to 4x minus 5, which is my length for AC, then I can solve this equation for x. And let's go ahead and do that, all right? So if I subtract 3x from both sides, 3x is going to cancel out. We're going to get 2 is equal to 4x minus 3x is 1x, so just an x, and then minus 5. All right, let's add 5 to both sides, and let's solve that equation for x. So then that cancels out, and we get 7 is equal to x. So now that we figured out what x is, all right, what we can do is we can now figure out what the length of AC is. Now, AC, remember, that segment length is 4x minus 5. Okay, so if I take 7 and plug this in for x of that equation, I get that AC is equal to 4 times 7 minus 5. And from here we have to do our math. All right, so 4 times 7 is going to give us 28 minus 5. All right, so then AC has a length of 23 units, okay? And that's how we figure out a problem like that. Hope you guys enjoyed this video. We'll talk to you soon. Thanks a lot. Bye.